Now the last two rules we considered are pretty straightforward. The next one is a little bit trickier, but it's also pretty intuitive. This is the rule of existential elimination, or existential instantiation. The way this works is that we take an existential claim, say that something is a cube, we come up with a new constant term that hasn't been used so far, say d, and we derive that d is a cube. Now we've already noticed that an existential sentence, something is an S, is equivalent with a disjunctive string affirming S of every single item in the domain. We would say, well, A1 is an S, or A2 is an S, or A3 is an S, and so forth, and that would have the same truth conditions. But this sentence here doesn't really tell us very much about what exactly is an S. And if we want to get rid of this sign by existential elimination, sometimes called existential instantiation, we can't operate the way we would by cases. So instead what we do is we introduce a temporary name. And the limitation on this temporary name is it cannot be already in use. So here's how we use this temporary name. In the course of a proof, we've come to something is an S, and from this, we're allowed to use this temporary name and say E is an S. And this is fine as long as E is not anywhere else in use. Here's an example of this and how this has worked in history. It so happens that Neptune was posited before it was actually seen through telescopes. And the reason for this is because telescopes weren't strong enough, but there were disturbances in the orbits of neighboring planets that could be explained by the existence of another planet that couldn't be seen, but that was causing differences in their orbit. So you'd say, there exists an X such that it's exerting gravity, and from this, taking a name that's not already in use, namely Neptune, we can derive this sentence, Neptune is exerting gravity. But again, instantiation only works if this name Neptune isn't already in use. If we had dropped in here exerting gravity Earth or Mars, then we'd be saying something very different, and it wouldn't actually be explaining the difference in orbit of these planets anyway. So the most important point is that the name here, E in our derivation or Neptune in our example, is not being used anywhere else in the course of the proof. Now that we have these three rules in place, existential and universal instantiation and existential generalization or introduction, let's see a brief proof that makes use of all three. Now have a look at the following. Every horse is a mammal is our first premise, and something is a horse is our second. There exists a horse. Finally, every animal belongs to Noah. Noah owns every animal. And suppose from this we want to derive Noah owns a horse. Going off of our existential instantiation, we can introduce a constant, call it C for Charlie, on 2, which just tells us that something is a horse. And the important point is to remember that this constant C doesn't stand for anything else already under discussions. We couldn't use this constant Noah, but other than that, we don't have any other constants here. So this is by existential elimination or instantiation. Now from premise 1, we can derive that Charlie is also an animal. For the sake of space here, we're going to combine two steps. The first is ELIM, and the other is conditional ELIM or modus ponens. We use this once more on 3 to derive that Noah owns Charlie. Now we can combine these to get Charlie is a horse and Noah owns Charlie, and this is just by a simple conjunction introduction on lines 4 and 6. And finally, down here we get 8 by a simple application of existential introduction. So there's a proof that uses existential elimination, universal elimination, and existential introduction, which are the rules for the quantifiers we've seen so far.